All right, so if we're trying to figure out if B can be expressed as a linear combination of those three given vectors, we are able to set this up as a vector equation if we'd like. Essentially, we're looking for some scalar multiple of that V1, 4, 0, 2, 1, added with some scalar multiple of our V2, and a scalar multiple of our V3. And we want to figure out if there are actually three scalars that would make this true, where I can add all of these and end up with that column vector B, 0, 1, 2, negative 2. And obviously solving a vector equation seems a little bit scary, but we know we can express this as an augmented matrix, so we'll go ahead and just rewrite all of those vectors. It was completely unnecessary for me to write the vector equation. I just did that so we could see that connection right between our linear combinations and what we had done before. And then we have our 0, 1, 2, negative 2. All right, so currently, it looks like we're a little overdetermined. We might be nervous that there's no way to do this, but there's no guarantee, right? We know that just because there are more equations than unknowns doesn't really tell us anything. It's possible that there is no solution. There's possibly infinite solutions. It's possible there's one. It really depends what happens when we go to do our reduced row echelon form. Now, a smarter person would just use technology, as the book said to. I'm not going to be a smarter person. I'm going to go ahead and do the Gauss-Jordan elimination by hand for this particular problem. So first things first, let's go ahead, row 1, row 4 have to swap, because I would love that 1 to be in a pivot position in row 1. 1, okay. And then I will be bad and do 2 row operations at once because I'm lazy. I would love for everything in that same column as my pivot of 1 to be 0. So let's go ahead. It looks like I'm going to do row 3 minus 2 of row 1 and row 4 minus 4 of row 1. That will get me what I need. That's going to be my new row 3 and my new row 4. Now, to mention and go back to our learning objective, I think 3, a number of folks did other things. They added like a negative row 3 to 2 of row 1. Our row 3, if that's what we're changing, whatever we're manipulating, cannot get multiplied in that same line. I realize you're combining 2 elementary row operations, but technically swap, multiply, or add a multiple of another row. Those are the only things we're allowed to do. So if we're replacing row 3, we had to have OG row 3 in that row operation. It can't be like a negative version of row 3 or any other multiple. All right, a smarter person would have prepped this ahead of time. It wouldn't be doing it on the fly. But no one's ever accused me of doing things that are smart. All right, so 2 minus 2 is 0. 3 minus 2 is 1. 1 minus 0 is 1. I almost said 0. Ugh. 2 minus a negative 2, so that's 2 plus 4 is 6. And then, moving on down, 4 minus 4. And then we have 1 minus 4. Then we have negative 2 minus 0. And 0 minus a negative 8. Just making sure I didn't screw anything up. It's very possible. Minus negative 8 is positive 8. I'm going to just fly too close because I'm going to be Icarus. I'm not going to check anything. It's good. It's going well. All right. So now we're going to move on. I like that I already have a 1 in the pivot position in row 2. So I can go ahead and swap that into the right position now, or I can wait till later. I'm going to go ahead and swap it in now. So I'm going to do row 2 and row 3 swap as my next row operation. So now I have 1, 1, 0, negative 2, 0, 1, 1, 6. Oh, did not give myself enough room in this matrix. It's fine. Well, it'll all work out. I'm already feeling not good about this. I feel like it's going to be a no solution baby based on those matching coefficients in column 2. But, who knows? Maybe it'll work out. I don't know. It's possible. It's possible there's still some weird linear combination I haven't thought of. In fact, I probably could have just looked at the answer in the book before I did this, but I didn't. Okay. And yeah, okay. So both of these are now row 3 plus 3 of row 2. That's my new row 3. And row 4 is also plus 3 of row 2. That's my new row 4. And so since I'm using row 3 times that in both places, I'm just going to go ahead and give myself a little cheat sheet here. So that way I don't have to think as much as I do these additions. So 0, 0, 4, 19. Ugh. 0, 0, 1. This isn't looking good for the home team. 10. Cute. And then 0, 1, 1, 6, and 1, 1, 0, negative 2. So if my whole goal here is just to figure out if there's a linear combination, I'm already good. I could be done. If I really want to prove this right to someone, because like me saying, yeah, I promise you there's no linear combination, probably not enough. Let's go ahead and just do a row 3 minus 4 of row 4. I realize I could swap those first, but as long as I get my contradiction row, I'm going to be happy. So I'm going to leave this one where it is for a second. Or REF be damned. All right, 0, 0, 0. And then we're going to have 19 minus 40, which is a negative 21. All right. And you'll notice I am not done. I have not, this is not in our REF form. I still have a number other than 0 in those rows with my pivots, right? My pivots of 1. Boop. We've got pivot 1, pivot 1, pivot 1, and we have non-zero things. And technically, I'd also need to clear up that 21. It should be a 1 as well. But that negative 21, none of that matters in terms of solving this particular problem, right? In terms of this problem, no, B cannot, oops. Be expressed as a linear combination. And now that I've done the hard work, let's go ahead and toss this into a matrix calculator. I'm just going to use Desmos instead of Sage or one of the other tools out there, just because I think that their matrix calculator is so intuitive and easy to use. I'm going to have to make her smaller though. Okay. New matrix, what were we at? I've already forgotten. We had 4 rows, 4 columns, that's 5. And then it was 4, I'm really hope I didn't script me just writing in these problems, but who knows. 1, negative 3, 3, 1. That is not, I failed there, 3 and 1. Okay, and then we have negative 2, 1, 1, 0, 1, 2, negative 2. All right, once we have that in, we simply just tell it, okay, great, that's my A matrix. Get me reduced row echelon form of that A matrix. And this is where I get my ones on the diagonal, and I have my contradiction row 0, 0, 0, 1 at the bottom, which confirms that if I had continued working, indeed I would have ended up at that particular solution. In fact, I probably could have just seen that, but then again, I have to like actually write the operations. So that's it. Like I said, same but different. We're still just writing things that don't originally look like an augmented matrix in an augmented matrix, and then doing Gauss-Jordan elimination and interpreting that result for the situation that we are currently in.